So I was asked to look at this old little whippersnipper, which is funnily named the Scorpion. Electro Scorpion. Now, I can't find out exactly how old it is because nothing's telling me, but I think it's about 10 years old. So it's been through its paces. The amount these cost these days, it's not really worth repairing. But I was asked to have a look at it, so I will. And it's a good opportunity to show you what I'm pretty sure is wrong with it. It's munted. Yep. I don't want to do that too much because I'm probably going to be laying waste to the commutator right now. But I'm pretty sure this is the same thing that's 90% of the time the problem in nearly every single power tool problem that's been used always. So we'll rip it apart and we'll have a look. I'm pretty sure this problem is the same problem that most of these power tools, especially this age, and just 90% of the power tools that I'm asked to take a look at, they all have the exact same problem. They're like, it was working fine, now it's not working good anymore. Straight away, I think I know what this is, what the problem is. So, should be a pretty cheap fix if I'm right. See, 9 times out of 10, when a motor's running like that, it's because the brushes are either worn down, or worse, the commutator's actually worn down itself. These brushes at first appearance seem to be making quite good contact. So both sides are like that, they've got the same thickness left, but that does not mean that the sacrificial part of the brush has not been used up. A lot of times looks can be deceiving. These springs might not be pushing down enough force, but that arc, that massive arc, normally comes from the gap that it has to travel. If the gap's too big for the current, it will have to get, the pressure will have to get stronger to jump and bridge the gap. It's the same as when big HV switching happens on top of power lines or in power stations you might see, because as the gap gets closer, or as you open up DC voltage, the potential is there, the current spikes to long enough and you get the big across. That's essentially what's happening in here, but as the commutator spins, it's changing that gap on each one of them little panos there, changes the gap slightly and gets enough potential when it goes. Weird explanation. Okay, so strangely enough, I've got the brush out and the brush looks fine. For all intents and purposes, this brush is a ready to service good brush. Still got a lot of length on it. As you can see, the brush holding slot there is almost relative to that size. I'd say anywhere on this, with the short usage this got, even though it is 10 years old, it's not getting run every day. This would have only been maybe 10 to 20% wear on this brush. I was expecting this to be, you know, cheap quality brush that just went shh. But no, the brush is actually quite good. This is not the problem. So the excessive arcing would have to mean that the commutator was damaged. However, on first glance, the commutator's fine. So we're gonna have to have a quite proper look. And this actually took me quite a little while to see, because on first glance, I assumed the commutator was sweet, but really, So I have a little bit of trouble focusing the camera any closer than this, so you're just gonna have to deal with it, and I'll throw in some shots with the phone blown up a little bit, probably over here, so you can see what I'm talking about. But on first glance, if you look at the commutator looks sweet. However, right about here, this bar here has quite a lot of pitting on it. So as you can see, if I start here and I turn it 90, you can see this one here is full of pitting. Again, I'll throw some photos up so you can see it real close with the iPhone. So pitting, 90 degrees, 90 degrees. And hardcore pitting is attached to the commutator ring. There is a winding. It's worth popping that out. We're going to pop this out. Right, so I finally got the motor apart. These windings around these laminations here, as you can see if you look really carefully in here, they all go individually to one of these plates on the commutator. So if one of these windings that wraps around and around and comes back gets a short, that's where we see that massive arc every time the brush in the motor, this brush, the pair of brushes will pass by each one of them at the exact same time, and once every rotation it's hitting a winding with a short, and you're getting that that we saw earlier, the massive arc, the flash. So when I first thought it would just be the brushes, I thought that these are worn all the way out and were either riding on the pin that they cast in the brushes, or they just weren't making good contact and there was a gap. However, what was actually happening is they were making perfectly fine contact, but they were hitting a dead short, which was bumping up the amps, causing a good lot of flash. That's why it was running terrible. So this won't only make massive arcing, this will affect performance. Because you can imagine now, if there is, say, 20 pairs of windings there, you've just dropped your efficiency right down. Alright, so this little T5 meter isn't the most sensitive meter in the world, so you're not really going to see as good as, you know, a better model. This is normally just checking for dead and that sort of thing. But what we'll do is, we can visually see, so we've got about 20, a little bit higher, but about 20. So that's about right. Now if we go over these ones where we can see have been burnt out by the arcing and the flashing, we should find one with a dead short. 7, that's very low. 4. So there we have it. The keep it simple stupid is probably the brushes are just worn out. You know, they are a consumable item in the things. Turns out brushes are sweet, windings let go. So what did we learn from this? Nothing. Just another one of the long line of things that I've fixed until they were even more broken. And before I didn't know how old this was, but judging by the guard, this was made in the 6th month of 97, so can't have been sold too much later than that. So looking at 21 years, not quite vintage, but getting there, getting there. Now this thing, 21 years old, I've just worked out, so I'm gonna have to go to it and say, like, look, you gotta buy a new one. Can I recommend Ryobi based on their last 21 years of service? Probably not. Their build, their everything is completely different. So what are they punching out these days compared to what they used to punch out? I dare say now they've probably got 18 volt brushless little motors in them. But around the workshop, I have been collecting a bit of Ryobi gear lately. Can't beat the price, and it's holding up. And 21 years out of this, not bad at all.